Welcome everyone to the GE Digital Energy Technical Training Webinar for the 8 Series Relay. Our agenda: first we'll review the software option that's required for 61850 communications. We'll look at the hardware configuration that we're going to be using and the wiring configuration. After that, we'll go into the programming. I'll show you how to create a settings file, how to use the IEC 61850 configurator, and how to write the settings back into the relay, and we'll do a verification check to verify the Goose messaging. So we'll start with the setup. From a software option point of view, you have to make sure that you have the 2E as part of your order code. The 2E is the only one that has the IEC 61850 option available in it. When you order the IEC 61850 option, you need to order it with the advanced communications, which means also that the copper port is disabled. This will mean that there's only 2 fiber optic connections available for you. These will be communicating at 100 megabits per second. So our hardware configuration that we're using will have 2850 relays communicating via fiber optics to a multi-link ML2400 managed switch. They'll be communicating at 100 megabits per second. Each port will have its own IP address. And in addition, we'll have an RTT connected to relay A as a means for contact input changes. The wiring configuration: this is the back of the relay. We'll have 2 850 relays connected via port 4 using fiber optic communications. One relay will be marked as bus A, the other one will be marked as bus B. Bus A will be publishing, bus B will be subscribing. Our connection with the RTT will be connected to the digital inputs into the back of bus A to provide digital contact status. So now I'll show you the programming portion. I'll show you how to create a set point file. There are 2 ways to create a settings file. One is to select one of the connections. You right click on it. You'll see this menu. You select Read Device Settings. The second choice is to go to the online menu, select Read Device Settings from this menu structure. So now I'll show you how to do this. We'll go into the live connection that I have, and I'll select the first connection. I'll do one in each manner. So I'll right click on this one, select Read Device Settings, give it a name and a location, select Open, and then select Receive. Alright, the file now has been saved. It's saved with a CID extension. Let's go ahead and save the second one. So I'll highlight it. I'll go to the menu on top, select Online, Read Device Settings. We'll log into the relay, log in as an administrator, enter the password 0, click on Connect. Give the file a name and a location. I'll call this one bus B. Select Receive. Now we've gone ahead and saved both settings. You can see here this is one for bus A, the other one for bus B. Now we'll go into the IEC 61850 configurator. The 61850 configurator consists of 5 tabs. The first one is labeled as ICD, CID. So these are the file extension types that the program will accept. There's a settings screen. I'll explain what that is. Reports, Goose Reception, which is our Goose subscriber, and the Goose Transmission, which is the publisher section of the programming. So let me go into first the ICD-CID section. I'll go into the programming. And let's open this up. One of the things that we have to be aware of here is we need to make sure that we change the default name of template to something usable. So let's just change this to bus_A. And remember, when we're using the IC 61850 standard, or sorry, the protocol, that we have to make sure that we have an underscore between two words. We can't leave a space or a dash or anything else. It needs to be an underscore. The other thing that we need to look at here is under communications, subnet. We'll expand this out till we get to address. We need to enable the port so that it will work with Goose messaging. So we'll just click on the drop down here, change this from disabled to enabled. We can save the setting. We can save it at the end once we're finished with all the other configurations. So these are the things that we need to be aware of on this particular tab. Let's go back to the presentation. The next tab is the settings. The settings are used to configure the deadband parameters for the metered values that are used for our reports. Now, in here we have our deadband configuration, and we have another configuration for the virtual input and also for the circuit breaker. So let me just go into this. So under settings, this is our deadband configuration. We have the different parameters, our different metered analog values. So this is real power, we have reactive power, we have apparent power, power factor, frequency, and as we scroll down the list a little bit, you will see phase-to-phase voltage, deadband for phase A-B, phase-to-phase voltage for the angle. So this is a phasor. So we have a magnitude and an angle. So a little bit further down, we have phase-to-phase voltage BC, magnitude, BC, angle. I'll go down a little bit further. So we have phase voltage for phase A, deadband, phase A, deadband for the angle. We'll go down even a little bit further. So we have neutral current. We have, so this is current for phase A. So you read this as mmxu, amps, phase A, deadband magnitude, and then amps, phase A, deadband for the angle. Now let's just go a little bit further down. There's phase B, phase C, our neutral currents, auxiliary voltage, and our symmetrical components. Now, let me go back and change it, the amps phase A. So the point is this: we can change this to be any magnitude we want. I'll change this to a value of 10. So what that means is anytime the magnitude changes by a value of 10, then it will start publishing that information into the report. Now this is to free up the activity on the network. So the only time it'll publish any information is if we exceed this deadband. From the virtual input point of view, this is the GGIO 3. So we can set up the enumeration to either use a value of a direct with normal security or the status only. We'll leave it with direct with normal security. The last part is the XCBR. So this is the circuit breaker. XCBR is the logical node for a circuit breaker. So what we're doing here is we're monitoring the position. This is used in the event of a breaker failure. So we execute a trip condition. The breaker doesn't execute within this amount of time. We'll execute a breaker failure condition. So let's come back to my presentation. The next part is the reports. So these reports are the reports that report back to the data management system. So in this screen, what we do is we can create and modify, delete report control blocks. We can communicate with up to 4 different clients. And of those clients, each one of them can have up to 4 control blocks. Each one of the control blocks can contain up to 64 elements per data set. So I'll explain how this works. So under reports, the way we add a report is by one of two ways. We can either select add a report down here in the bottom left, or we can select on the device, right click, select add a report. We have a choice between buffered and unbuffered reports. Now, the difference between the two reports are this. A buffered report, if the communications are severed, then the information that is collected up until then is stored in a buffer. Once the communication has been reestablished, then the information is forwarded on to the data management system. In an unbuffered report, these are less mission critical type signals, and if the communications are severed, then the information is lost. Once the communication is reestablished, then it starts sending the information as normal. We can select up to our 4 different clients. Here's our different choices, 1 through 4. So let's start off with a selection of 1. We'll click on Next. It prompts us for a new data set. We'll click on Next. So here's our report control block naming. Let's change the report identification to reflect our bus A. So let me come back. So this is bus A underscore A underscore report 1. And to add our data, what we do is we just expand over here on the reports. We have all the logical nodes listed here that are available within the 8 series relay. So we have logical node 0, we have our physical device logical node, MMXUs or metered and monitoring logical node, phase instantaneous overcurrent is what this is representing. We have neutral instantaneous overcurrent, ground instantaneous overcurrent, time overcurrent. So if you go down the entire list, you'll see all the different logical nodes that are available within the 8 series relay. So let me step back for a second. I'll go back to the instantaneous overcurrent to keep things simple. So we'll start off with this. We'll expand on this. We'll expand into the data objects. And here we have the different parameters that are associated with the 62850 protocol. We have mode, behavior, health, and then we have STR, which is our pickup. If you hold the cursor over it, you'll get a display that indicates that. And OP is our trip condition. So since it's an instantaneous overcurrent condition, what I'll do is I'll expand on the operate. And we have a choice of either going with a trip on any 3 of the phases, or we can become specific and select individual phases as well. So let me grab the general, which is any one of the 3 phases. And now once it's been populated here in the data set, we can see that this is the logical device is an 850. We have a prefix of phase. The logical node class is an instantaneous overcurrent. The logical node instance is 1. The domain name is an operate. The data name is general, and the functional constraint is status. Let's step down. Let's grab another signal. Phase time overcurrent. Once again, we'll expand on data objects. We'll grab the pickup, drag and drop. So this is the pickup based on STR. We can also do the same thing with directional time overcurrent. So we're just dropping signals in here for our reporting. I'm going to come back to the operate, do the same thing. Alright, so here are some of our mission critical signals. If we want to add another report, we can do so by right clicking on here again, add another report. We can go with the same client or with a different client. Click on next. Now that we've already got a report already in here, we can have a choice of either creating a new data set or modifying the existing one. So let's create a second new report. So I'll call this, once again, bus A underscore A. I'll call this report 2. And what we'll do this time is we'll select some metered values as part of our report. We'll expand on the MMXU. We'll expand on data objects. And once again, as part of the 61850 standard, we have our mode, behavior, health. We have our different metered values, total watts. So our real power, our reactive power, apparent power, power factor, frequency, phase-to-phase voltage, phase voltage. We have our amps. You can see as I move my cursor over the different headings, the name appears. So let's keep it simple. How about we just grab phase voltage? We have a choice of either phase A, B, or C, or neutral. We have a choice of either going with instantaneous values, this is the instantaneous value, or the value based on the deadband. So let's select it based on the deadband. We have a choice of either magnitude or angles. So let's grab the magnitude, and let's grab the angle. This is for phase A voltage, and then we'll do the same thing with the current, and I'll explain it a little bit further. So grab the deadband version of the current, grab the magnitude, the angle. So you can see once again what we have here. We have our logical device, we have our logical node, which is our MMXU, our logical node instance, our domain name, so we can see, read this very easily, phase voltage for phase A. So this is the magnitude. The second one is for the angle, amps phase A, the magnitude, amps phase A for the angle. We're using the functional constraint MX. Alright, so let's grab one more report. So I'll do it from here. Right click, add a report. Let's go to the same client again. Let's go in and create a brand new settings file again. Or sorry, brand new report. We'll backspace, and I'll select bus A again. So I'll call it report 3. And this time what I'm going to do is I'm going to take some of our inputs and outputs. So I'm going to refer down to the GGIO signals. And I'll explain what each one of these are. So under GGIO2, when I expand the data objects, once again we have our different indicators. So the first one is our contact input 1. I'm going to grab the status value of contact input number 1. Let's put a second one in there as well. So this is indicator number 2. So this is contact input 1, contact input 2 from the 8 series relay. We'll go to GGIO 3. GGIO 3 is our virtual input. We'll expand on that. We'll grab the status and the second one as well. GGIO 4 is our virtual output. So the virtual output is the resultant of our flex logic. So if we have two inputs performing some function, the resultant of the flex logic is a virtual output. The virtual output is used to drive contact outputs, LEDs, send Goose messages. So let me just grab this as well. So our contact output. GGIO5 is our remote inputs. Now our remote inputs are important because this is what the subscribers are mapping the information to. So let me just bring this in here as well. So GGIO5 is our remote inputs. And last but not least, GGIO6 is our contact outputs. So the status of our output relays within the 8 series relay. So just drag and drop that in. And there we have that. I'm going to skip over the Goose reception because I'm dealing with the publishing side, so I'll go directly right into this. So the last tab is the Goose transmission, which is our publishing signal. We can have up to a maximum of 3. We can publish up to 3 Goose messages. The multicast mask in this case needs to have a 1 in the last position. So what that means is this, that in this first octet, this character is a binary, needs to be a 1. So whether this character is a 1, a 3, a 5, 7, Bravo, so forth, so on, that last character must be a 1 for this thing to publish the Goose message. Alright, so into the Goose transmission. Once again, it's a Goose control block. We can do this one of 2 ways. We can either do it from the bottom here as add Goose control block, or we can right click from here. We'll add a Goose control block. We'll have to give it a name. So this is bus A. I'll call it Goose 1, just to give it a name. Time to live. Let's change this to 1,000 milliseconds, so that's 1 second. There's an application ID in here. Every time you make any changes in here, the configuration revision updates by 1. We have Vlan Priority. Now the Vlan Priority is set in such a way that the standard indicates that priority level 7 is the highest priority, 6 is the next lower one, 5, 4, 3, 2, and then they do something strange here. 0 has a higher priority than 1. So 1 is the lowest VLAN priority. So 7 being the highest and 1 being the lowest. The typical is number 4. Now, to add items to the data set, once again, let's go in here. Let's grab for instance, let's grab the contact inputs, which are located under GGIO2. We'll just expand on this. We'll grab the indicator, the status value, and there. That shows us the contact inputs. Let me add an instantaneous overcurrent condition as well. So phase, instantaneous overcurrent 1. We'll expand on this. I'll put the operate signal on. Any one of the signals. Done. So this completes the publishing side of the Goose message. Let me save it. This information is automatically stored into the settings file that's configured as a CID. So let me close this. We'll now go ahead and program the subscriber side. So I'll grab the second settings file. This is bus B, will be the subscriber. We'll open up the 61850 configurator. Once again, we need to come in here and make some changes on the ICD CID tab. We'll change the default name from template to bus B. Once again, make sure that you have the underscore between 2 words. And underneath the communications, let's make sure that we enabled the Goose for port 4 and port 5. So this will enable this. And this time we won't go into the settings, the reports will go straight into the Goose reception. Now the way we do this is one of 2 ways. We can either right click in the block here and select add IED, or at the bottom of the screen we can select add IED here. So let's do this. Add IED. So because we're dealing with bus B, we'll grab the other one, bus A. This is our publisher that we're subscribing to. So here's our signals. All we do is drag and drop them in. So one of the things you need to be aware of is we're mapping to the remote inputs. Now this is important because we're going to be verifying the communications based on the remote inputs on the bus B bus B relay. All right, so here we have GGIO2 status indicator, and the second remote input will be the phase instantaneous overcurrent operate. All right, so let's save this. All right, that's great. Now, the next part of this is we're going to need to write the settings into the relays. So I just wanted to show you this slide so you can subscribe up to a maximum of 8 Goose messages, and the mapping of signals is placed in the remote inputs. All right. Now, from a verification point of view, first thing we need to do is we need to write the settings into the relay. So in our offline window, we can select the device, right click, we get this menu structure that comes up. We'll select write settings file to device. Or the second choice we have is going to the top of the screen, going to the offline and selecting write settings to device. Now I'll do the same thing here. So we can do it one of two ways. So what I'll do here is this. I'll right click. Sorry, I'm just moving this up a little bit. So I will select write settings file to device. I'm going to send this settings file to the publisher. I'll need to log into the relay. Administrator 0 is the password. Select connect. Now, there's a note here. Settings file successfully written to the relay. Note, please reboot the relay to view the changes. Anytime there's any changes in the communications, whether you're setting the IP address or you're changing the configuration of the 61850 settings, you need, once after you upload the settings of the relay, you need to reboot the relay. We'll do that after we finish uploading the second settings file. And then we'll do the second one from the upper screen. Sorry, we'll do the second one from the upper screen here, offline. Select write settings file to device. Click on send. We'll need to log into the relay again, an administrator, and the password is 0. That's great. File successfully written to the relay. We're going to reboot this as well. So to reboot the relay, we'll expand our device. We're going to need to go into set points. Under set points, we need to go to commands. The very last item under commands is our reboot relay command. So we'll select this, press yes. The relay is now going through a reboot sequence. While that's happening, we'll do the same thing to the other relay, bus B. Same thing again. Under set points, we'll go down to commands. Again, under commands, very last item, reboot relay. And now we'll just wait for the relays to to finish the reboot sequence. Alright, there's the first relay, and just waiting for the second one. So the first thing I'm going to do while I'm waiting for the second relay to reboot, I'll go right into the first relay. I'll clear any errors that I have in here. So right now the programming is set to not, the installation is set to not programmed. So I'm just going to come in here into installation and change this to programmed. So we'll log into the relay after reboot. With 0 is the password, click on connect. We'll change this from not ready to ready. Okay, that's great. That's the first relay. And we'll repeat the same process with the second relay. So under status, under set points, device, installation. So we're logging into the relay again. We're going to change it from not ready to ready. Good. So now the relay is fully operational. There's no errors on the front of the relay. Let's confirm that our contact inputs, our publisher is, the inputs are operational. So let's go to contact inputs. I'm going to close the switch on my RTT device, make sure that it's working. It's not working. Let's confirm our voltage thresholds. Sorry, let's go to inputs. Alright, here's our problem right here. Got to change it to 17 volts. My RTT device only puts out 24 volts. So this is why I needed to reduce the voltage level. That's great. So let's confirm it again. So I'm closing my switch. So this is on bus A. So what we have here is this. I'll close the switch. Good. Everything's fully operational. Good. So this is our publishing signals. Let's leave this up here. Now, on the subscriber side, let's confirm that this is being received at the other end. First, we'll verify the communications. The way the communications are verified is by going to set points, to communications. Sorry, my mistake. We need to go into the status, and then we're going to go to communications, and then we're going to go into the Goose status. So, reviewing this, and my contact input is closed. This is from our publisher. Our subscriber is not seeing the Goose message. That means we have an error in our programming somewhere. So I'm going to close these down. I'm going to take a look at the publishing side. I obviously seem to have an error. So let's open this back up. IC 61850 configurator again. Let's go to the Goose Transmission. And I have missed the changing this bit right here. This, remember I said it had to be in the binary, it has to be either a 1, 3, 5, 7, so forth, so on, 9, alpha. I failed to change this, so I'll make this an F3. And here's an excellent opportunity to show you the maximum, how we know that we've already got more than enough Goose messages published, is we click on add a Goose control block, or we do it this way, or right click. We can add more Goose messages. Here's a second one, here's a third one. If I try and add a fourth one, it comes up with a message saying that we've exceeded our maximum number. I'll click on OK. To remove them, I can right click, select Remove Goose Control Block. Great, and we're back to the original. We've got the 03 in here. Click on Save. And we'll try this again. Now I'll need to reload the settings back into the relay again. This time I'll change the input contact inputs to the 17 volt level up front. Good. Okay, now let me load the settings into the relay. Once again, right click. Let's do it from up here then. From the offline window, select Write Settings to Device. We're sending it to Bus A, the publisher, and we'll click on Send. On completion, we're going to need to reboot the relay again. Settings to Device, Bus A Publisher. Okay, looks like we're having some problems here. Okay, so let's try it this way then. Let's try it from the offline window. Let me just raise the window up a little bit so we can see it. So I'll right click, Write Settings File to Device, Bus A. Prompts us for the password. Terrific, successfully written to the relay. We'll click on OK. Now we'll need to go in and reboot Bus A. So once again, this is under Set Points. Sorry, this is under Settings all the way down to the bottom to Commands. Last item under Commands is our Reboot. And now the relay is rebooting. So now we're just waiting for Bus A to reboot. And we'll go back into the programming screen and change the installation screen from not programmed to programmed. Okay, the relay is now up, so let's go into installation. Okay, so let's verify that the contact input status is actually changing on the publisher side. So we'll go into the status, contact inputs. Let me just minimize this so we can see this. And from the subscriber, we'll verify the Goose status again, make sure it's active. It is on. And let's go to the remote input. So closing switch 1 should turn on remote input 1. Good, they're both following each other. The second thing I'm going to do is I'm going to inject current. So go to my metered value. So just show you that I'm actually injecting current, creating an overcurrent condition, and the second bit is turning, on. Okay, I reset my current, and the bit returns back to 0. Now the next part of the exercise that we're going to do is we're going to publish the contact status, and we're going to echo it back to the originator. So that means that bus A is going to publish a signal to the subscriber, and the subscriber in return is going to republish that same signal, and the originator is going to receive it back as a subscribed signal. So let's go ahead and do that. So let's close down these screens. We'll come back we'll start off with the subscriber first, because what it's going to do is it's going to republish the input signal that it received. And then what we're going to do is we're going to use the oscillography to measure the speed at which it took for the signal to be echoed back from the originator. So we'll go into the 6150 configurator. And remember the Goose reception, we're going to look at GGIO2, the first indicator. So this is what we're going to publish out on the transmission side. So as I open up the transmission tab, we're going to add a Goose control block. So I'll right click, add a Goose control block. I'll call this bus underscore A, we'll call it echo, for instance. Make sure that we change this bit to that it has a 1 on the end. We'll change this to reduce it to 1000 milliseconds. And now the data that we're going to add here is going to be the GGIO5. So we expand on this. Our indicator 1, this is our remote input. This is the one that we want to send back to the originator. Here it is here. We'll save it. We'll close this. Now we'll open up the originator, which is bus A. And we'll open up the configurator for this one. And now we're going to go straight into the reception, and we're going to add the relay from bus B's Goose message into this configuration. We're dealing with bus A, we'll add in bus B. Here's our echoed signal. We'll grab the signal, we'll drop it in, click on save, and we're going to reload these settings back into the relay. So let's keep it straight again. So bus A will load into the bus A relay. So write settings file to device, back to bus A. That's great. So the first one was successfully written to the relay. Now we'll do the same thing with bus B. Writing settings file to device, bus B relay. All right, good. Successfully written to the second relay. So we're going to reboot. We're going to reboot both relays. So we'll start off with bus A, coming down to that same screen. Under set points, I'm going to go down to the command screen. We're going to select reboot. Okay, there's the first relay being rebooted, and we'll go into the second relay, bus B. Under set points, all the way to the bottom, commands. Very last item, reboot. So there's our second relay being rebooted. Close this off. So I'm just going to minimize the screens so it's not as confusing. Alright, the first relay has rebooted. Let's go in and let's go back to the device screen so we can change it from not program to program under the installation screen. Sorry, we'll log in as an administrator. Password is 0. We'll connect. Okay, let's try that again. Great, we'll change it from not ready to ready. Alright, let's try that again. There's the first relay. We'll do that to the second one as well. That's bus A. Now I'll check on bus B. Set points, sorry, device, installation, log into the relay. Let's try that again. Okay, let's try that again. Okay, that's great. So let's confirm from the publisher side that everything's still working. Contact input will close. Fantastic. Let's confirm under the communications that it's acknowledging the Goose message from relay B. So we'll go to Goose status. Fantastic. This is showing the Goose status is on. So relay A, bus A relay is subscribing to bus B published Goose message. So this is what this is indicating that it's on. So it's acknowledging it. So let's check on the remote input. This is where the echoed signal is being fed back into. Let's confirm the signal. So let me just minimize this so we can see both. And we'll close the switch. And you can see the remote input. This is the echo signal coming back from relay B, or from bus B. Now, let's go one step further. Let's set up the configuration so we can check the timing of the signals from the time it was published to the time it was echoed back from the other relay. So now we'll go into the oscillography, the transient recorder. We'll set this up. So the trigger source is going to be the contact input closure. So contact input number 1 on. And I will copy in this signal into as one of the digital signals that I want to monitor, and remote input number 1. So the point is this: when I close the switch, the waveform capture is going to trigger on contact input number 1, and in the capture we're going to record input 1 and the echoed signal back to remote input number 1. Okay, so this is saved. Let's go ahead and try it. So let me just show the status again. Contact input. Remote input, we're closing the switch. Great, I'll open the switch again. And let's check in the event recorder first. So here we are in the event recorder. We can see that we've closed the switch. It triggered the transient recorder and the remote input shortly thereafter. So we can do this one of two ways. We can do this. We can show the difference here. Okay. So we can see that this was this amount of time. So let's see what the oscillography shows us. So, to magnify the screen, we press and hold the right mouse button, draw a square around the area of interest, and what we'll do is we'll use the blue and green lines as a means of measurement. So the blue line, you can with the red line, the red vertical line shows the trigger point, so this is our contact closure. The green line is showing our remote input that's been echoed back, and we're looking at, let's magnify it even further. So I'll make sure that underneath the red line is our blue line. It's used for measurements, and the return signal took 2 milliseconds, so there and back. This concludes our 61850 webinar. I want to thank everybody for viewing this.